Welcome back. Our today's topic is going to be the first recommendation algorithm. Thus far, in this module, we have spent time discussing 1. What a recommendation system is, 2. Where a recommendation system can be useful, and 3. What is the basic problem of recommendation. As we have seen, in its simplest form, the problem of recommendation system is filling missing entries. For example, we can think of the available data as a sheet of an Excel file. So you got rows and you got columns in your Excel file. In the context of Amazon product recommendation, rows would correspond to customers and columns would correspond to products. In the context of Netflix, rows would correspond to, again, customers, columns would correspond to movies, and the cells or the entries in the cells would correspond to the ratings. In the context of Yelp, it is about whether a customer is going to be interested in eating at a restaurant or not. In all such scenarios, a large fraction of entries are actually missing. After all, each customer ends up eating at a very small fraction of restaurants in a town. So if we threw a dart at random on this big Excel sheet, it will most likely end up on an empty cell. So really, that says that data is really sparse. In the next few chunks, we shall discuss algorithms for filling these missing entries. Now, to fill these entries, we will leverage structure in the data. In today's module, we'll start with the simplest possible structure and then evolve to more complicated structures as we go along. The simplest possible structure: the entire population thinks alike, eats alike, sleeps alike. A bad assumption in general, but excellent place to get started on this long journey of designing recommendation algorithms. The resulting algorithm is effectively what we shall call population averages. Let's start with our classical Yelp scenario. Remember, we were looking for a restaurant to have dinner, and Philip and I had settled on having an American cuisine. So let's assume that you're going to go to Cambridge or anywhere in Boston for that matter to have American cuisine. And let me add a twist to it. You want to celebrate an occasion. You have successfully gone through first few chunks of recommendation system, and so you're happy to go to an expensive restaurant. So now you search. Various restaurants come up as a result, just like a search result, but filtered by your preferences. There are too many restaurants qualifying your constraints. So now what? Well, you need to order them somehow. And this is where recommendation system becomes really useful. And this is precisely what Yelp does. It provides options for you to rank your results or order them. One of the options is by the proximity, which is not really relevant because remember, we are happy to go anywhere. Another option corresponds to how pricey the restaurant is. Again, we're keeping only most expensive restaurant, not sure it is relevant either. At this stage, we are looking for what restaurant is really good. Yelp is ordering for this by suggesting order by rating. Great. Various people who have been to these restaurants have provided ratings to these restaurants between 1 to 5 stars. And one can use these ratings to produce ranking for restaurants. And this is what Yelp is doing in this option. So one way to compute these rankings is as follows. 1. For each restaurant, assign it a score which is equal to the average value of the ratings that it has received. Okay, so for example, if a restaurant has received 2 ratings, 5 and 1, then its average would be 5 plus 1 equals to 6 divided by 2, which is 3. 2. Order the restaurants as per this score. So restaurants with higher score gets higher rank, restaurants with lower score get lower rank. That is it. In a sense, this is what Yelp is doing when it's showing you that option of order by ratings. Super easy. If you are building a system, this can be obtained using a native SQL-like database queries. Therefore, it's very easy to implement and scale. In our Excel sheet visualization, effectively, we are filling out missing entries for a given cell by taking the column average of the entries. In practice, one has to be a little bit more careful than just taking averages. To understand this, we'll have a small digression. So suppose you have a coin like this, which has 2 sides. It has a head and it has a tail. Now, every time you flip it and toss it like this, comes up, lands in my hand, and either it's head or it's tail. Now you want to understand what is the chance that this coin, when I tossed, comes up head or tail. Now a general belief is for all of us is that, well, coin is built symmetrically, so there will be 50% chance that it will be head, 50% chance that it will be tail. But that may not be necessarily true. Somebody might have rigged it, maybe the physics of the coin is different, who knows. So maybe you and I want to figure out exactly what the bias is. Now in this case we can verify. How can we verify? Well, we can measure it. We can toss this coin many times and observe its outcome. So I toss a coin once, comes up head, coin twice, tail, head, tail, etc. Now while I'm running this experiment, at any point we can state the chance of a head showing up, right? Because I can say in so many tosses, let's say 100 times, I have observed 46 times heads, which means that 46% chance for it to be coming up head. Every time when I toss a coin and it comes up head, we are assigning score 1. Every time tail shows up, we assign score of 0. In that case, all I'm doing is I'm computing average score. Now mapping it back to our Yelp setting, if we think of head as a like or 1 and tail as dislike or 0, then effectively average score of a coin, which is same as computing average rating of the restaurant, the way we discussed some time back.